Hi learners, welcome to IoT Design and Applications course. So in this session we are going to see IoT applications in various sectors in detailed way, because earlier we have seen a simple application wherein we have just seen the basic introduction of it, but in this session we will be dealing more with various sectors of IoT applications, and to be precise with enough, so we will be seeing industrial internet of things, that is mainly for industry 4.0, that we will be seeing in the next lecture. So welcome to this. So in this what we are going to see, so what are the different industries here: home, cities, environment, energy systems, retail, logistics, industry, agriculture, and health and lifestyle. So all these things we'll be seeing. So in what way we can able to design applications for these industries, and we'll be seeing main focus will be on industry. So how IoT is suitable for industry. So first thing is, we have already seen this in the previous in the week number 1 we have seen this on IoT for homes. So here in detail, so what we are seeing here is smart home is smart lighting, then smart appliances, then intrusion detection, and smoke gas detectors. So these are the 4 things that we can able to do in a home to make a smart home. But in this in smart lighting means, what we meant is controlled LED lighting systems and IP enabled lights. So that means that, so using internet protocol we can enable the lights through Wi-Fi, and we can have various according to the mood requirement of the particular user, we can able to change the color of a particular light, so that we can able to use it here, controlled LED lighting systems. Then smart appliances, so in the entire house we can have thermostats, so that we can able to control the temperature of the home. So like whenever during summer season we can enable the air conditioning, during the winter we can enable the room heaters and other stuffs, and we can use RFID tags everywhere, so that the RFID tags are passive enough, so that's way we can use. And open remote, so we can design a remote for our purpose, that we can control the entire home appliances. Then intrusion detection, so we can have passive infrared sensors, PIR sensors. So if any person is waiting outside the gate, so or if there is temperature change of any human beings or anyone cross near the door, it will be alerting you, on based on sometime we can able to get a short video clip as emails too. And using door sensors we can have it, so whenever somebody try to open the door, it will immediately alert with an SMS or with a phone call or something, that we can able to have in a smart home. Next thing is smoke gas detector. So main issue in this is LPG leakage, so liquefied petroleum gas, so the what we call as a cylinder here, so that will be having a major issue in particularly in homes. So that leakage, as well as the carbon monoxide leakage, can be detected in the smoke gas detectors. So designing all these stuffs will make our lifestyle very easier, and it will be designed as a smart home applications. So next thing is the IoT for cities. As we have already seen this, what are the different things that we can able to see in IoT for cities here. In detail we can see that. So these are the different things in IoT for cities. So first thing is smart parking. So in the smart parking, in the sense that parking availability, monitoring, and dynamic pricing. So the parking is a very Herculean task nowadays, because having a vehicle and getting a parking is a different issue. And using the dynamic pricing auction and parking availability, we can able to park our vehicle at a different locations. Smart lighting, so again here greenhouse emissions and huge electricity usage can be avoided with the help of smart lighting. So that means automatically, according to the time of the particular day, the lights will be on and off, and the lights will be keep on monitoring the life of the bulb, or life of the ligament, life of the filament, and all these things can be monitored using this smart lighting systems. Smart roads, here is travel time estimates according to the speed of the vehicle. Alerts for poor driving conditions. So if somebody is driving in a different way, so there will be alert sent to the driver that the driving condition is not good or something. And traffic congestion and accidents. Traffic congestion and accidents can be then. And structural health monitoring of the buildings. So vibration levels in bridges and the high-rise buildings. So structural health of the particular buildings and the dams and even the bridges can be monitored using the SHM systems. Then surveillance. So surveillance is a major task, that what kind of peoples are roaming in the roads, and what kind of conditions they are, what do they bring, and theft and all this stuff can be monitored using surveillance systems based on infrastructure, public transport, and events. Then finally, emergency response. So MIG response is if there is some unprecedented event happens, so how to detect the adverse event that is happening, and usually data, audio and video feeds can be recorded and then sent for the or monitored for the purpose of the smart city application. So this is the next application that we can think of. So next is the environment. So in the environment we have weather monitoring, so the changes in the weather, and air pollution monitoring. So air pollution monitoring means levels of carbon dioxide, carbon monoxide and nitrous oxide and nitrogen dioxide. So all these things will be monitored in air pollution and weather monitoring system. In the noise pollution, where we have we can create an urban noise map. So that means that in which area the noise is very huge at a particular time. And sleep disruption and stress are the major constraint for the noise pollution. So if you encounter more noise, usually the users will have sleep disruption and stress. And noise visualization map also will be provided in the map software, so that any user one who crosses a particular domain, so they can able to arrest the noise or they can avoid that particular route. So that way noise pollution can be monitored and that can be controlled. So recently you would have heard about in one of the city in Mumbai in India. So what they have done is during in the particularly in the signals, most of the people they horn their vehicles, so they keep on horning. So whether irrespective of what signal they will be having, so what they have done is they have deployed a sound sensor. So when the sound sensor crosses a particular decibel, automatically they need to wait for a more period of time. So that means that the more you honk, the more you have to wait. So obviously the particular noise get reduced over a period of time. So this kind of noise monitoring system and things can be controlled using this IoT. Next thing is forest fire detection. Since this environment, so how we can detect forest fire is methane sensor, temperature sensor, infrared sensor and visible light sensors for detection. So forest fire usually detected with the help of these 4 different kind of sensors, and there will be some more other sensors also will be playing a major role in detecting the forest fire. River flood detection. So here use of ultrasonic and flow velocity sensors. So according to the flow of the water and the ultrasonic vibrations, so we can detect whether there is any problem with the river flow detection. So next thing is energy systems. So in energy system is mainly on smart grids, renewable energy systems and prognostics. So that's how this energy system IoT is used here. So usually smart grids, what do they do is they distribute power energy, they generate, and the consumption is automated. So entire power distribution, generation and consumption will be automated. Real-time demand response and management. So according to the response and management, real-time demand, so that means that how much power is needed for a particular day or a particular month. If there is any event is going to happen nearby, so how much amount of power will be distributed to the particular area. So all this can be decided on smart grid. So every entire application can be controlled using a simple IoT application. So IoT device and an application. And renewable energy sources, the wind energy demand, solar energy demand, all these things can be integrated along with the smart grid. Prognostics, so that means that the critical wear and tear of the power plants turbines are being monitored. So that means that since the production of power energy, usually what happens is every year there will be some maintenance will be going on the power plants and the turbines. So in case during the continuous flow of operation, so the turbine may because of wear and tear it may get worn out. So during these conditions, so how they monitor the particular health of the particular equipment is that we call as prognostics. So prognostics is under the industry 4.0 standard, and now remote monitoring also there, and remote prognostic, diagnostic, all these things are available now. So those things can be modeled for energy systems. So next thing is retail industry. So in the retail industry, how IoT plays a major role in the retail industry. So retail industry is gearing up like anything in the particular in the entire world. So how this retail energy is been modeled by IoT. So one thing is inventory management, smart payments, smart vending machine. So these are the 3 things. But apart from that, there will be some more simple kind of applications also there in retail industry. But here mainly RFID based tags, as the tags are passive. So that means mainly the RFID tags are passive. That means it doesn't need any power or energy to activate it. So RFID tags generally they are passive. So that's why in most of the even a small even a hairpin to a clip or anything. As a small pin also it have a RFID tag in most of the retail industry, so that the inventory can be managed, as well as the theft can be the shoplifters can be prosecuted according to this RFID base, and that is a cheaper solution. So inventory management is handled with the help of this RFID tags. And smart payments. So as of now we use smart payments on Bluetooth and NFC. So I think it is gearing up in the market now, so that the people need not wait in the queue for smart billing and payment. So directly when they enter the particular shop, so as you've seen that there is a shop called as Amazon Go, so wherein the users enter the shop by just showing their smart card or a debit card or some card they want. Whenever the Amazon gives a card, it will be swiped when they enter the shop. So once they procure all the things and come out of the shop, automatically they will be billed to the particular credit card attached to the smart card. So this kind of things are happening with the help of NFC and Bluetooth. So NFC is near field communication, which is high frequency, low distance, and the Bluetooth as we know that it is one of the major standard. And even nowadays most of the cards they have a Wi-Fi enabled card, so even you need not swipe it, just to show the card near the card machine, so the amount will be detected. So that's how the smart payment systems have been deployed in retail industries. Then smart vending machine. So actually smart vending machine is not so popular in our country in India, but in some of the European countries it's very a smart vending machine is a good size. That means customer choice of operations in one machine to another machine. Suppose if let's say if a chocolate delivery machine is there, so if a user goes to chocolate machine and he taken 2 chocolates and the stock it's emptied there, so automatically he want to go to the next machine, so without affecting the user preferences. So when he go to the next machine, wherever he left off in the machine number 1 will be continued in machine number 2. So that kind of smart vending machines also deployed in so many supermarkets and so many shopping malls. So that also can be used in retail industries. So next thing is this logistics. So logistics means how they transmit information, how they transmit shipments, products via this fleet tracking. So in this here, route generation and scheduling. So first thing is route generation. So cloud based advanced route guidance, dynamic vehicle routing. So automatically a vehicle is been driven by a driver, so it will be the route will be automatically programmed. So that means that the driver has to go in a particular route, he should not diverts its route. So in that case, if anything happening, so the dynamic vehicle routing will be controlled via the cloud based system. So even some of the vehicles nowadays, it comes with the dynamic routing. So that means that the vehicle movement can be uh, monitored, and so we can call something like geofencing. So geofencing means beyond a particular geographical area you cannot move your vehicle. So this geofencing also now enabled in some of the logistics arrangement. Then fleet tracking. So in the fleet tracking, usually we can see the GPS based tracking. Alerts are generated when routes are changed. So automatically when the routes are changed, automatically then an alert will be sent to the particular shipment manager, where he can see that whether the vehicle is going in the correct direction or the routes are being changed. Then supply chain optimization. So based on this, supply chain will be completely optimized based on this fleet tracking. Then shipment monitoring. So fleet tracking and shipment monitoring both are same, but in the shipment monitoring here is, suppose if there is any food is being transmitted in a shipment, so whether the spoilage of food it is been monitored. Conditions inside the containers are monitored for temperature, pressure. So what kind of temperature a particular product is being taken. Suppose the product is been free of frozen item, it has to be in a freezer. So whether the product is there in the maintain the particular temperature, pressure and everything, so that will be monitored in the shipment. Then remote vehicle diagnostics. This is one of the major area here. Onboard diagnostics. So we have an onboard diagnostics. So when you switch on the engine itself, automatically the engine before it starts, it's diagnose all the critical components of the engine and the vehicle, and it will just analyze the particular performance and send it to the remote diagnostic manager. Then the speed in RPM is computer, rotations or revolutions per minute, and the coolant temperature inside the vehicle, and status of the vehicle subsystems. So the tire pressure or the braking systems and coolant systems and air fuel mixture system. So all these things will be analyzed. So that's what we call remote vehicle diagnostics. So next thing is agriculture. So in agriculture we have smart irrigation and greenhouse control. So mainly these two are the main things. So smart irrigation is we have to save water and electricity. So when the motor has to pump for water and how much amount of water is needed, so we can go for different methods called as drip irrigation. So in most of the Gulf countries they still use drip irrigations because drinking water is a major issue there. So drip irrigation means so drop by drop of water will be drop by drop of water will be given to the plants given to the plant so that they can get sufficient nutrients and energy via water and the sun. So watering schedule for plants. So this is what the watering schedule means. So according to the schedule, the water will be poured to the plants for nutrients. And greenhouse control is, so we just keep on monitoring humidity, soil moisture, light, carbon dioxide and temperature. So because plants need more carbon dioxide than human beings, so in that case, so how this carbon dioxide is being monitored and soil moisture and the wetness in the soil and the light and the corresponding lighting conditions, how this thing is monitored. So smart irrigation says that once you deploy all these sensors in the field, so how it can be monitored will be taken care by this application. So next thing is IoT for industry. So this we will be seeing in detail. So mainly thing is machine diagnosis and prognosis and indoor air quality monitoring. So these are the main. So machine diagnosis prognosis means, so we call something called as CBR. So CBR means case based reasoning used based on the past experience. So based on the previous history of the machine's condition and other things. So we call something like case based reasoning. Based on this technique, so what kind of past experience we encounter, accordingly the problem will be solved, or it can be the machine issues can be diagnosed. Cloud based storage and remote diagnosis across the geography. So even if equipment is in India, but the equipment is manufactured at Germany, for example, so sitting in Germany, a remote diagnostic manager can able to take over the entire machine from India, and he can able to find out or prognose or diagnose according to the conditions of the machine. So even because we cannot make the expert to travel across the geography, instead of that he can sit in his place and then he can monitor that. So these kind of things are very common nowadays in the industry 4.0. So that we'll be seeing in detail in the next slide. Then indoor air quality monitoring again. So since it is industry, there will be so many gas emissions. So what are the different gases? We can use different gas sensors. So carbon monoxide is a major one, and nitrous oxide, nitrogen dioxide. So all these things will be monitored in the industrial segment. So next thing is health. So health is one of the individual monitoring system. So here we can see that health and fitness monitoring. So nowadays it's becoming very common that everyone uses some kind of sensor attached to human body. Like for example, we have heart rate, we have pulse meter, we have body temperature, we have accelerometer. So even for elderly people, whether they are sitting idle for a longer period of time or sleeping, and while sleeping they might have get some cardiac arrest or heart attack or something. So accordingly the conditions will be monitored, keep on it will be monitored. So for that we use 2-axis accelerometer. So how this accelerometer helps in making the patient idle or movement. There is a movement in the vehicle, in the particular human being. And ECG, echocardiogram and electroencephalogram. So this is for brain signals and this is for heart signals. So this also been monitored with a simple miniature smartwatches. Then wearable electronics. So we have wearable like Google Glass and smartwatch, walking aid for the blind. So all these things they are just made use of this Internet of Things to make the power efficient devices, and with the limited processing and limited memory we can achieve these kind of devices in the health and lifestyle segment. So now having said all these applications, now we are moving towards the design of this IoT. So in this design, so what we first think of is machine to machine with IoT. So there are different techniques that what a machine to machine uses, what an IoT uses. Because earlier, before IoT was introduced, earlier also people were using in industry there was onboard diagnostics was there, then remote diagnostics was there. But in what way they are differing from existing IoT or existing machine to machine? So that's what this session will be. We'll see. So first you can see that this M2M versus IoT. Here you can see M2M applications are here at a separate thing, and M2M core network, it is completely on a wired network. Then there is a wireless network. So we have wired, we have wireless that have access to these applications. So these two will be accessed via this wired network, and we have a M2M gateway across it, and here these are the M2M area networks. So these are some equipment and these are some cameras that are monitoring it. So that means this M2M system architecture is very simple, saying that we have this M2M applications which are access to some intermediate network called as core networks. The core network could be wired or could be wireless, and via a gateway, so this area network can be controlling. They can monitor and control this M2M network. So in this M2M gateway, so what are the components of M2M gateway is? What are the components is, we have this IP routing. So that means that this is a switch or a router. So via that we are routing it. In the M2M gateway we can see native protocol protocol translation, proxy, and these are the things on a virtual node. So we cannot have a actual node, but it's a virtual node. So native protocol means the protocol which is very native to M2M will be used, and translation, because the entire IP is based on a standard. So IP is based on a standard. So how this translation happens, because M2M gateway can be designed by anybody, any vendor or any manufacturer. They can design their own rules and regulations for operating inside their network. But how it can able to convert this into this IP? So for that we have a protocol translation. So this protocol translation will convert the native protocol request to the existing protocol. And we have a proxy also. So proxy means, as we know, that instead of on behalf of one particular node, a particular node behaves. So that's what we call proxy. So proxy means we are diverting the traffic through a particular node in a particular network. So that's how this M2M gateway contain. And this is the MTM node. Actual MTM node, it talks to the standard with the help of this MTM gateway. So this is the property of MTM gateways. There are so many virtual nodes, number 1, number 2, like there are so many virtual nodes. So all these virtual nodes in terms talk with the router and give it to the M2M nodes. So MTM area networks, you can see what are the different protocols and standards: Bluetooth, Zigbee, WPAN, 6LoWPAN, MBus, wireless MBus, UWB, ultra wideband, Modbus, and Z-Wave. So there are so many MTM area networks. So using these MTM area networks, they can able to control any kind of diagnostics devices. Okay, so now the difference between this IoT and M2M. So in this case, we have different items here: communication protocol, machines in M2M, hardware with a software emphasis, data collection, and application. So I will just give a readout document here so that the learners can able to read it in a descriptive way. So I have just compared it to both M2M and IoT in a simpler way here. So communication protocols up to the network layers are used in M2M, whereas protocols in the top layers are used in IoT. We can see in the next slide. So up to the network layer, here up to the IoT deals up to the top layer, from in the top layers mainly. So machine to machine with things, homogeneous machine types within M2M network. So that means that the machine should be of same category, same manufacturer and same thing. So that's what we call homogeneous, particularly on machine to machine. But communication between things with unique identifiers called as IP MAC. So as I already told you that these IP MAC are all standardized one. So we are going with heterogeneous things also, but mainly the communication between the known protocols. But here it is homogeneous machine types. So that's in the area network. Hardware and software emphasis more on the hardware. So M2M deals mainly on the hardware, whereas IoT deals mainly on the software. So that's why the bottommost layers up to network layer, they are mainly deal with the hardware and the data link. Here the top layers mainly deal with the software. Data collection is mainly on local storage, on-premise storage. So mainly on M2M network, the storage will be locally stored rather than it is stored in cloud. But IoT mainly the data is stored in the cloud storage. So in the applications here, so we have diagnosis, service management, on-premise, enterprise support. So this is what the applications here. Whereas here we have cloud apps like remote diagnostics, management application. So that means that mainly deals with cloud. So whenever if you design any application like smartwatch, if you want to control any device or anything, so usually what happens in smartwatches is the data will be stored locally. So if you, let's say if you are having a sleeping pattern, so the sleeping pattern data, even without internet connection, the sleeping pattern will be stored in the smartwatches. But later on, once you connect to the network or once you connect to the Bluetooth with the mobile phone linked to it, automatically the data will be stored to the cloud. So that's how it happens. So mainly IoT applications deals with the cloud, whereas the M2M applications mainly on stored in the on-premise enterprise applications. So this is the difference between this M2M and IoT, and you can see what are the different things. So I have shared you this here, M2M here, M2M. So this is up to the network layer. So below this network layer we call M2M, whereas above this we call IoT. So this is how these top layers deals with IoT, bottommost layers deals with M2M. At some point of time we need both M2M as well as IoT. So during those applications we can use all the layers of it. So just you can see, to recap everything here, HTTP in the application layer, constrained application protocol, WebSockets, message queue telemetry transport, XMPP, extensible message presence protocol, data distribution service, and AMQP. So these are the some of the protocols in application layer. They can talk to other thing via IoT. Similar transport layer we have mainly TCP and UDP. Again they can talk to TCP and UDP. The network layer we have IPv4, IPv6, 6LoWPAN. Here also we have IPv4, 6 and 6LoWPAN. So here we mainly deals with the M2M, machine to machine communication. Then finally this link layer and the physical layer in the bottommost layer, either we use Ethernet or Wi-Fi or low data rate WPAN or WiMAX or 3G LTE. Here the same way we can use it here. So in this difference M2M and IoT, we can able to control any machine sitting at a remote location, whether it could be from the top layer or the bottom layer, we can able to control. So sometime, for example, sometime back I have just been to a particular industry, automotive industry, for giving a training to their employees. So I happened to understand from them that the machines are being produced in Germany, and when the machines are delivered to India, if there is any issues happens to those machines, locally the data will be stored on board in the machine. So whenever the particular engineer they wanted to check the diagnostics, they want to have some frequent checks in every 3 months once. So when they want to check it, the data is being pulled to the cloud. So through the cloud and through the remote diagnosis, they could be able to check the what happens to the engine and what is the conditions of the engine. So the prognostics things have been the health of the particular machines will be monitored in a different geographical area. So these things happen with the help of both M2M as well as IoT. Okay, so with this session, so there's a questions for the learners. Which are the protocols used in M2M? So this one have an answer for this. And how data collection differ between M2M and IoT? So I have just given you the slide, so don't refer only the slide. Also see the study document and on what way the data collection differ between M2M and IoT. So thank you for listening. Thank you, friends.